Hi, I'm Andrew Bunnell, and today let's look at the collisions experiment. So here I got some data already up, the kinetic energies in an elastic collision. But let's briefly look at the applet. When you use the applet right here, you're going to change your own settings. You're going to click play, and you're going to look at the plot, and then you're going to take the data and put it into Excel. Just as a reminder, Control A, Control C, and then that will select everything, and then you can Control V into your cells. And so you'd start out right here in B3 and Control V. I already have my data set up, so I'm not going to do that. Don't forget, you're going to make an index so that you can have row numbers. And then you're also going to create headers for the velocities of ball 1 and ball 2, the kinetic energies of ball 1 and 2, and then the total energy. As a reminder, the velocity is the numerical derivative. And so you need the difference between one after that time index minus one before divided by the difference between one after in time and one before. And to help with the instructions and to make sure you copy the right things, it actually asks you to put this cell in, which will give you an invalid value. But when you copy it over to the fitting spreadsheet, there's going to be some more instructions to delete that top and bottom row. Now, to find the kinetic energy, we have to use our kinetic energy formula, 1/2 times mass times the velocity squared. And we're going to use the velocity from that we find because the velocity is going to change through the motion of the collision. And so that's going to give us this dip right here. Now, don't forget that you need the settings and the mass and the velocity of your settings so you could recreate your data if need be. There's no exact instructions in the procedure to do this, but it would be wise to create a little table of what your settings are so that you can go back to them. Now, you're going to do the same thing with ball 2. And notice my mass was different, 0.6 kilograms and times velocity squared. And then total kinetic energy is just simply that. You're going to create a graph by selecting the time column and then holding the control, and then these 3 columns right here, and insert charts, scatter plot, just like that. Now double click on the points and use the paint can to make the markers smaller. Marker options, built in, and make them smaller, not to 0, to 1 or to 2. And do that with the remaining of the data. Don't forget to add a chart title and axes titles as well. Just as a reminder, to do that, you'd have to be on chart design and you'd add chart element. Click down, click on axes titles, and add that. I'm going to go ahead and delete the chart. And I want you to notice that this week we're not focusing so much on uncertainty, and I don't really have error bars here. You still can report what your uncertainty from your before and after your collision is by reporting the standard deviation of the residuals. So let's talk about what you're going to do for that part. So right here, eyeballing it looks like it's the same before and after, but we don't exactly know unless we find the average and the standard error of the average before and after. And so you're going to highlight a point here before and record that value, and you're going to highlight a point here after and record that value. And once again, even though it doesn't specifically say to put it in your spreadsheet, it's a good thing to do that. You can put those times there. Then what you're going to do is you're going to copy over the time column first, and then the total kinetic energy column next into a blank spreadsheet. I've already done that here in the elastic before. And then it also tells you to delete the top row, so you'd select it, right-click, shift cells up, and you'd go to the very bottom row and do the same thing, and then you'd make a copy of the worksheet once again for the elastic after. And then go back to the elastic before, and you delete all the data after that point in time. So I deleted all my data after 0.47. And the instructions say to start out with 0.01 as the uncertainty. That's going to be the uncertainty for almost the maximum velocity. And then you're going to use the spreadsheet to calculate what the uncertainty is in the velocity. Next, you're going to fix those two boxes and hit Perform Regression. And your data shouldn't have any big dip in it. If it has a big dip in it, or like there's some points way down here, that means you didn't select the correct set of data, and you included some of the data after the collision. And so part of this is a graphical analysis so that you can see if you selected the right data. And then after you'd copied that value, the standard deviation, the residuals, over the column, you can come over here and record these results. Don't forget to use the number digit to decrease the digits to the proper rule of 1 and 2. You're going to repeat the same thing with the elastic after, but this time, as you select your data, you're going to right-click Shift Cells Up again. And over here, you can see that I had a lot more data after the collision based on the initial settings I had. And then I once again copied the value over the standard deviation over to the Y error. And then coming down here, I decreased the digits. Now next, even though it doesn't say to do this, once again, you can use Excel as a calculator. So you can copy this, Control-C, and just paste it here on the spreadsheet right here. And now you can do a z-score. You can do a z-score directly here on the spreadsheet. And because now both of them have uncertainties, you have to divide by the square root of each of the uncertainties. And I also included an ABS on top, just in case one is if I pick the wrong one to be, the smaller one to be first, it gives me a positive answer. And you can decrease digits on the z-score as well. So that's basically what your graph should look like. Now, depending on your settings, your graph may look different than mine. Then you're going to right-click on this tab and create a whole new worksheet. And you're going to take data with the other applet. Let's see. Here's the settings that I used. Once again, you're going to Control-A, Control-C on the data table, and then paste it in to this one right here. Now, if you notice, gave a little error this time, and so it saved this one value as a text. So to fix that, you can just convert that to a number. It doesn't really change your data analysis in this one, but it could in a different one. So having pasted that there, you also have to update your formulas. Basically, you have to change the masses if you chose different masses in each of the kinetic energies. Once again, it doesn't say to do this, but it's helpful to keep your information, and so I updated this table as well to my new masses and my new initial velocities. Now, I didn't really use this, and so I'm just going to go ahead and delete that. That was just a copy over from before. But this time, it asks you to estimate the energy loss. And so you're going to click on a point up here. Well, not click on it, just hover over. And it gives me a value, 0.294. That's slightly different than the number I got here before, 0.294. So I'll just type it in. And then down here, if you notice the oscillation is changing, and I just hovered over here and 0.0139. So 139. And I estimated where it's going to balance out to. Once again, based on the initial settings, this graph might look a lot different for you. And here's my energy loss based on my inelastic collision. And that's basically it for today. Thanks for watching.